So,
So
go ahead.
are the negative values because of the rotation of the tool?
It's
Like I know like on a router you can only router one way because of the way the bit's spin. Is that what we're
right.
saying?
So what, like, if you're machining, when you guys get into the 109 class, you'll talk more about climb cut and conventional cuts. But if I'm doing a climb cut, whatever direction you're climb cutting, as it's wrapping around the part, is going to be positive, negative values, depending on what direction you're machining.
Yeah.
So my point to that last one is that's not an issue. You guys are still seeing my screen?
Yeah.
If I do a radius, I know that this is going to be only positive, negative values, right? It's not going to be, or sorry, it's going to be either all positive or all negative. There should be, it should be perfect. We'll do a simple extruded surface. Why don't I see my surface? Oh my god, this thing must be huge. I wasn't paying attention. Yep, I made a huge curve. Oh, I just was at a bad angle. Okay, I forgot to rotate it. That's fine. I'll select OK. If I wanted to do a quick check on the surface, and I didn't know, you guys didn't see me just do it, you're just told, hey, make sure the surface is machinable. What's the first thing I'm going to do?
Check the radius. Do the surfacic curvature analysis.
Why did I get this? First thing you got to do, before you do anything, is go to your view mode and make sure that you're in the shade material. Okay? Then I can use surfacic curvature analysis. My quick check was
Starts with a G.
Gaussian curvature.
The gosh dang curvature.
Gaussian curvature. Rotate around. Okay, I'm not really going to see anything because I know that this surface is perfect. We're going to hit this limited here. Use minimum maximum. Okay, and now because I use minimum, we got to remember to hit that use minimum maximum. There's no change of radius. It's all just one radius. That's why we just see zeros, and it's all just one color. Which is what you would expect, right? I should see that.
Yeah, with that.
Now, I want to machine it with a 1/2 inch radius. What do I do to check that?
Limited.
Limited. 1 inch cutter. 2 inch cutter is what I have, so it's got a 1 inch radius. Select my surface, say OK. Yeah, no problems. Not going to have any issues. Okay. I'm going to go back to the sketch. I haven't tried to do this in a while, so let's see what I can do here. I'm going to put points equally spaced. One. Okay. I'm going to do points on this curve. I'm trying to remember how to do this. Let's do 25, I guess. Nope, that's not going to be enough. God, why are you... I'm hiding all those constraint points. I'm hiding all the constraints so I can see the points. I'm going to create a circle. Wanted that to be smaller. I'm going to break this curve at that point. So when I go to trim, trim that curve to this curve, and I'm going to trim this curve to this curve. Oh, you sucker. This curve to this curve, this curve to this curve. This curve to this line. Oh, what's going on here? I need this curve there. No, it looks like it's still shooting up. Let's try. Let's just try and quick trim this out. Oh, shoot. I'm going to exit out. What the heck? That curve went all the way around. Oh, this part moves so sloppy here. Deleting that out. When I did my trim, it must have extended it. Okay, let's see if I can exit out, see if it'll work. It's so ugly, I don't like it. And it might not like the fact that I don't have tangency in there, but I'm trying to force that to happen anyways. I'll grab the sketch. It won't even let me grab that sketch. Oops. Oh, those points should be fine. Okay. Oh, why? I should be getting the whole thing. When I go to review, shade this, do the Gaussian curvature, select that surface, use minimum maximum. It should be turning colors in here. And this has been an issue I've had since the 3D experience. Why it's not changing the colors. Let's try and get rid of this. Yeah, I don't. It should be. This should be a green, and then this should be drastically changing colors. It would be changing red to blue because you got positive, negative values going on in there. I'm not sure why it didn't continue on with this curve here. And then the other thing is, if I do my radius check, limited, and we change this to 1/4 inch radius, select that surface. This used to turn red. I don't know why it's purple, but it's telling me if you got a 1/4 inch radius in there, we're not going to be able to machine this area. We can machine this area, but we can't machine this area. Now, I know that looks drastically crazy, but I used to get this all the time when I worked on Boeing surfaces. Because at Boeing, they have all these points are coordinates we would have to type in. So all those points that I had created, and it'd literally be hundreds of them. To create the spine, you'd have to create all the points. Well, I guarantee you some of them weren't perfectly along the curve. One would be above and one would be below, and we would get positive, negative values. That's why we get ripples in our surface, because that's how it was designed. And what the problem is, it's fine if it were like way over here and way down there, it just kind of smooth itself out. But the points that they give you, they give you 150 points along a curve. All the points are really close. So all it takes is one point being down here and one point being up here, and the spline's trying to hit those points. And they would use a feature called spline, which would force it to go through a point instead of using arc comp smooth to generate the smoothest possible curve to find the median of all the points. That was one of our biggest issues when we'd have to work with the surfaces. Plus, let's say that radius is 0.3, right? And I need to do a Teflon finish a 1/4 inch apart. What's going to happen when I try and offset this a 1/4 inch? So if I grab this surface and grab this, and I try and offset it a 1/4 inch, why do I get an error message?
Because you shrunk that radius.
Zero radius.
Yeah, I'm getting that 0 radius. Remember I talked about that in the 193 class? When you offset, you can only go so far. Well, when you're looking at a big, huge surface, a 1/4 inch surface should be no problem. Unless they got the points all screwed up. And then when I try and take their surface and offset it, I can't do it. I would have to break this into tons of little surfaces, recreate a surface that would work, and then offset it myself. It's like it really shouldn't even be that way, because I'm now changing the integrity of the original engineering surface they gave me to get it to work so I can make my part. And that's why it's important to understand, oh yeah, you got it to work here fine, but what's going to happen to the offsetting surfaces? Those offsetting surfaces can't have positive, negative values. So I'll undo this. Are you guys understanding what I say when I'm saying positive, negative? Oops. That these are positive, negative, right? Because no matter which direction I go, up or down, right? If I'm coming up, there's that little curve right there. Is that a positive or negative direction?
The lower half?
This little tiny 0.3 radius right in the very, very bottom. That's negative, right? Oh, this didn't get trimmed back. This is negative, and then what direction is this?
Positive.
And then this direction goes,
Negative.
and then suddenly switch back to
Positive.
So if you have a surface and there's positive, negative values in it, and it's supposed to be like the outside surface of the plane, there's no way that's going to work, right? It should not have positive, negative values. That means you've got ripples in the surface. The only reason it would be positive, negative values if there's a ripple in the surface. Does that make sense?
Yeah.
Yeah.
Okay, so when I say in this Word doc, positive, negative radius values, that's what I'm referring to. And the radius of the surface must be greater than the cutter in order for the cutter to not undercut the engineering part. So again, there's no way I'm going to get a 1 inch, half inch, 1/4 inch radius to get in there and machine that out, right? So when I try and run the tool path with the 1/4 inch cutter even, it's not going to be able to do it. And this is going to be why. And being able to understand how to analyze it and verify that stuff will be important to figuring out why it's not working and what adjustments you need to do to fix that. But I don't understand here. I trimmed you. Oh, great. Now it can't handle it. I don't know why I can't handle that surface. Should be able to make that surface. I'm not really sure why I can't extrude it, but that's the general gist here. You cannot have this happen. And I know you look at it, I'm like, oh, there's no way someone would make it like that. Well, they do it all the time. Again, the main reason that happens is because they're given point coordinates to work with, and they make the curve go through the point coordinates no matter what. And you really shouldn't do that. You should be trying to create a curve and let the surface or the spline develop the best, smoothest curve it can create based on your points. All it's going to do is fix your miscalculation of your location of your points. And that's how that really should be done. Okay? So the one I didn't talk about is the reflection lines. I don't have anything really great to demo on that, and I haven't done it in a while, but we have to set up a direction of which we're going to view. So how I've used this before is, imagine, if you will, we're back in Portland working on, does anybody know what semis they build down there? Nobody? It's the Freightliners. So what we would do is we would take the average person sitting in the driver's seat, and we could create reflection lines looking out the cab to see how far over the nose of the plane, or the nose of the hood, they would be able to actually see the road and their peripheral vision. So you know how you turn the flashlight on and you have a circular beam on the ground? Imagine if you could change the angle in 1 degree increments to make that circle bigger and bigger or smaller and smaller. And we would do reflection lines, reflection curves to see where someone's actually going to have visuals on the road or the sides on the periphery. Yes. Or you could run reflection lines on a surface, and what you would look for is like little gaps. So let's say you are shining the light on the wall, but the light hits the table, right? Well, where it hits the wall is not going to be a perfect circle where the light is hitting the table, correct? So the reflection line, the curves that intersect the surface are going to be jagged or offset, and that's how you know, hey, something's weird about this surface right here, because it should be nice, smooth reflection curves on the surface that would show that. All right. Let's see. Just build another arc real quick. What? Another very, very common technique. Holy cows, I've made that thing huge. Let's maybe shorten that up a bit with the demo. Is to create planes. Repeat. Point down, planes, repetition. On this curve, on that curve, why not? Why can't I do that? Let me try and put a boundary curve on that. Why don't I see edges here? I'm going to try and limit it here and over here and reverse that arrow, and then planes repetition. I'm going to grab that boundary curve I just created and we'll do 50 planes. Well, that's about right. It's very common. Select OK. So I've got 50. Oh, David. Forgot. Under this boundary curve, we're going to do points and curves, but I forgot to turn on the planes. We'll do 50 of them. Select OK. And then I'm going to take that plane and we're going to run an intersection on those. We're going to intersect it to that surface. Select OK. And it's a very long and boring task, but we would analyze this curvature this won't do it. We used to be able to pull up a chart on this and it will show us a graph, which I can't find the icon that will do that now. But we could pull up a graph and it would tell us, it would do a graph and we could see the chart if it was going to go up and down, positive, negative values on that one particular spline, because sometimes it's hard and you just got to kind of spot check that surface and check each curve as you go along that surface for your analysis on that curve to see if there's any issues. Okay, but that's what we would do, is just try and analyze just that one curve and see if I got anything weird going on. If I go to measure item, I'm trying to measure that curve, measure item. If I get a radius value, I know I'm good, because now I know that this is just one constant radius. So I'm not going to have any issues with that. That's as smooth a curve as CATIA is going to be able to make. And if it can't machine it, there's nothing I can do to make that curve better. We have to redesign or do something different, because that's as good as I can make it. Alright, so that's going to conclude what I want you guys to know about surface analysis. Okay, you take this and I want you to make pictures of everything to kind of demo each one of these things. Also, to have as reference, you want to keep this somewhere handy. As soon as you get to production, make sure you know how to check surfaces to see if things are right. If you can catch these errors, you've got a real good chance of being able to get a surface that's going to be something that the other groups can work with, whether it be another engineering group designing from your part. So for example, if you're doing the OML surface or the MDS master dimension surface for a car or airplane or boat, let's say you're doing the hull and they're going to make ribs on the hull, well, everything's going to be based on that surface that you create. So they'll be using the surfaces you create to create the ribs on the hull of the boat. Or you could be making a hood on a car. The surface you create for the hood is going to be the surface they use to create the tool fixture to hold the hood in place so that they can fabricate it. So it's very important to have good surfaces. Without a good surface, everything else will be crap. Whoops, I should say not good. And then the there's one other thing I was going to add. Dang it. You want to make sure that your surface is machinable. You can work with it from other companies and for tooling. So if that surface has radiuses that are too small or discontinuity and tangency, or they're not touching, then you've got issues. It's not going to be something I can machine. And I can tell you more times than not, and to my surprise, even now, because I thought this would be resolved by now, where these are not issues in production. But I had a meeting with a group that's on the advisory board that NC's parts, and they say, yep, we still have all the same problem. I'm going to show you something that's still a very common problem. I'll just do a spline. Exit out, and I'm going to create another spline. Whoops, thought I picked spline there. Do a surface. Are you kidding me? Wait a sec. What? I thought I created 2 sketches. Obviously I didn't. You can see that the elements are not touching. So what is the problem here? What's the term I'm looking for that?
Non-adjacent.
They're not adjacent.
Yeah.
You guys hopefully can clearly see they're not adjacent. What is going on? Oh, I keep forgetting to rotate my part. Select OK. Okay, they're not touching clearly, right? So I've seen this trick where you join the 2 surfaces. Okay, so here luckily the joint's telling you, hey, you can't do that, they're not touching. Well, you can change this merge distance to 1/4 inch. Maybe 1 inch. So sometimes you can screw with this where you'll avoid that connectivity error, but that doesn't fix that situation, correct? So you're not supposed to screw with this. Okay? So people go, well, let's try this heel thing. I'm going to grab this surface and preview that. And select OK. Select OK. There's something I have to change to get that to work. But see, it's recognizing it as one thing. Now, under the heal command, you have options. And I think I can change the merge distance. Select OK. Oh, well, actually, let me take a look here. Can you guys see that?
Yeah.
It's not touching anymore, right?
Yeah.
But I healed it. So there you go. I just created a healed surface. But I totally changed the integrity of what was going on here. Which probably had to change because it can't be this. Right? So I've seen people, they just go ahead and heal it and machine it and nobody knows until, you know, the plane crashes and then they're wondering what happened. But until that happens, everybody's happy. So I'm just saying you got to watch out for that, and that's what that heal command can do, which is great if it works. If you're making cartoons, heal it. That's fine. If you're making something that's critical, you better double check the heal to see if that's something that's gonna still work. See if it'll still fly. Alright guys, that concludes my demo today for your surface analysis, your final demo for probably the most important class I teach, is understanding the surfaces and working with surfaces. If you're gonna build buildings, you don't need to know surfacing. If you're going to work on things that are aerodynamic, such as marine, aircraft, automotive, where aerodynamics is important. If you're going to work on things that got to be aesthetically pleasing, you're going to want to know a lot about surfacing, where they don't have all sharp edges and such. Okay. That concludes the demo here. Now your job is to go through and see if you can make an example of each one of these.